Hey, welcome to today's code experiment. Today I'll run a few code experiments so that you better understand list indexing and type conversion. Now the code that I'll be trying out are single lines of code, so for that reason I'll be using the Python console. It's best to use the Python console when you're just executing one-liners. So you saw that if the user entered some input and we store that input in a variable, for example, if the user enters 5 and then you see a now is a string, you see the quotes here, so a plus 10 would not make sense. Therefore, you want to convert a to an integer using the int function, and perhaps store the output in a new variable or maybe in the same variable. It's up to you. I'll store it in a new variable, b. So now b plus 10 makes sense. So b is an integer. You see it's without quotes, and this has quotes around. Now you might ask, why are types important? Why can't we just have 10 and it doesn't matter if it's a string or a number? Why do values have to have a type? Well, I'll answer you that with an example. So again, a is a string, b is a number. Now if you do b times 10, guess what you'll get? Yeah, it's 50. So 5 times 10, you get 50. Now let's try times 10. This is what you get. So in Python it is not possible to add a number to a string, but it is possible to multiply a number with a string. And the output you get is that string multiplied 10 times in this case. So 5, 5, 5, 5, 5, 5, 5 at 10 times, and you get a new string. And of course you can have everything like high times 10 and you get high 10 times. So back to the question we asked, why is it important to have types? Well, the interpreter wants to know the type because it understands better what you intend to do. So if you intend to have that string multiplied 10 times, then you want to have that as a string type. And then the interpreter knows that it is a string type, so I don't have to do a math multiplication. I do a string multiplication if it's a string type. And if you as a programmer mean to do a math operation, then you want to make sure that this value is an integer. So having types for values is important to communicate with the interpreter. So things have to be as explicit as possible. Right, the next experiment. If you do int high, you'll get an error. So that's obvious. You can also use floats. Float high, you will get an error again. So it doesn't make sense to convert that string into an int. And it doesn't make sense to convert that into a float. So floats are decimal point numbers. If you convert string 10 to a float, you'll get 10.0. So that is different from converting string 10 into int. You get 10. So again, we have a different type here. The distinction between floats and integers is not as important as the distinction between strings and integers. But still, you'd want to use floats whenever you are working with continuous data. So if you have a variable which is the temperature, then you want to work with a float. If you are working with whole numbers, such as the number of persons in a company, you want to work with integers. Now, Python has this implicit declaration of types, so you don't have to use the float class when you create a variable. So if you just say x is equal to 10.1 and you check the type of x, you'll see that x is a float. But if you do y is equal to 10, you'll see that y is an integer. So if it doesn't have that dot, it's an integer. If it does have that, it's a float. And of course, if you use quotes around it, it doesn't matter if it does have the dot or not, type of z is gonna be a string. If for some reason you want to convert a number into a string, you can use str. You not only convert integers to strings, but also floats to strings. You could ask, when would you need to convert a number into a string? Well, you'll see that when we create apps, then this str function can sometimes become useful. For example, if you want to write some text in a text file via Python, there is a method for that, which you'll learn later on in a few days from now. And in that case, you cannot write number data types to a text file. So if you have a number, you'll have to convert it to a string and then write the output in that text file. And then the number would show in that .txt text file or other file formats that Python is able to create. Let's run a few experiments on list indexing now. So let's create a list. My list is equal to A, B, and C. The first thing I want to make sure you understand well is that each of these items is treated as an object. So you can extract the object, you can store it in a variable, for example, as z is equal to my list 1, and z will be string b. So the type of z is b. Sorry, the type of z is a string. That b was another variable which we declared somewhere in here. So z is a string. And with that we extracted the item with index 1. So A has an index of 0, B has an index of 1. That's why we get the string B. And of course you can do other operations. You can say z is equal to B, you get true. Similarly, you can say my list 1 is equal to B, you get true. So my list 1 and z is the same value. So both these point to the same value. Now, how do we get the index of one object? Let's say we want to know the index of B. To do that, you need to use mylist.index, a method, and provide the object you want to know the index of, and you'll get 1. So that is the index of B. So index is listed in the list method. If you scroll here, you'll see index. Now, let's try this method with underscores. So it has double underscores in the beginning, double underscores at the end. All these methods with double underscores are actually used by Python internally. We don't need to use them. But what if we do? So let's try that mylist dot underscore underscore set item underscore underscore with 2 parentheses. So this is the same syntax as here. Now this method takes 2 arguments. The first argument is an index. So let's try index 1. Index 1 points to string B. The second argument is the new value you want to set for the item with index 1. So let's say D. You press enter, you check my list, and you'll see that D has replaced B. So that was the previous list, now the list is updated. So that there is the equivalent of saying my list 1 is equal to the new value. So let's try E this time. Now my list will be updated. So now D is gone, E is the new item. So which one should you use? This or that? The short answer is use this. And actually when you use this, on the background, the interpreter actually calls the setItem method. So every changes that are done are being done by methods. But the Python code developers have been nice and they have provided this simpler syntax for very common methods such as setting an item. Similarly, there's also a getItem method. So my list dot get item with double underscores, and let's try 2 this time. I did a typo obviously. So get item with 1t, and we get C. So the item with index 2 is C, and so that is the equivalent of, try to guess it, well, this. So you get C. My list stays the same in this time. So in this case, we're not changing the list. Some methods, such as setItem, change the list, and some other methods simply access some information from the list and they don't change the list itself. So that was a long video on code experiments, but plenty of information. So thanks a lot for following. See you.